Let's finish this up really quick, and sorry about the speed of it. This is section 1.6, and it'll be, I guess, at the end of the exam. This first one is an example of a rational exponent equation. And because the part with the rational exponent is already isolated, I know that to get rid of that ugly exponent so that I can get at the x, I have to raise it to the reciprocal power. But if I do it to one side, I have to do it to both. On the left-hand side, the 4/3 and the 3/4 cancel each other out, so the x minus 3 will come straight down. On the other side, when I put 125 to the 4/3 into my calculator, I get 625. Now to solve for x, I'll move the 3 over to the other side, and my final answer will be 628. Number 23 actually is a quadratic-like form, but the exponents are a little different than I expected, so we know that that is a u substitution type problem. I'm going to let the middle term variable equal u. I'm also going to let the lead term be u squared. So if I rewrite it, I get u squared minus 10u plus 9 equals 0. I'm going to solve that. Now I'm going to factor. If you're allergic, you can use the quadratic formula. Just remember that these are still just the u's. So after you get u is equal to 9 and u is equal to 1, you'll still have to unsubstitute. So up here, when u is equal to 9 and u equals 1, I'm going to come back up here and say, I know that u is actually equal to x squared. That guy never gets used. So I'm going to get x squared equals to 9 when I unsubstitute, and x squared equals 1. Now to solve for x, I'm going to take the square root of both sides because it is a square root method problem. We're going to end up with the square root and the square canceling. We get x. On the other side, because I physically took the square root of both sides, we do get plus and minus, and the square root of 9 is 3. There are two more answers over here. I'm going to take the square root of both sides, same thing as before. Square root and square cancel each other out. We get x. The answer on the other side will be a plus or minus because we did physically take the square root of both sides, and the square root of 1 is 1. This next one is also a u substitution. We're going to let the middle term variable equal u, and we're going to let our lead term equal u squared. Because I can replace it with u squared and u, I end up with a really nice little quadratic that I'm going to factor, but again, you can use the quadratic formula as long as you remember to unsubstitute when you find the u's. I'm going to factor it because it is a type 1, and I'm going to end up with a u of 4 and a u of negative 1. I didn't show where you're going to have to set it equal to 0 and solve, but that's what we get. Now, I'm going to unsubstitute because I know that we're not looking for u. We're looking for x's. So x to the 1/3 will be equal to 4. To get rid of an ugly fractional exponent, we're going to raise it to the reciprocal power. The reciprocal of 1/3 is 3, but if I do it to one side, I'm going to do it to the other. This lets me get an x of 64 as one of my answers. I'm also going to unsubstitute the u here for x to the 1/3. I'm going to raise both sides to the reciprocal power again, 3, and I'm going to end up with an x of negative 1. Over here, this is like number 22. We've got one rational exponent. Always start by isolating that. So start by moving the 36 over to the other side. Then I'm going to divide both sides by 4 so that I end up with x to the 2/3 is equal to 9. To undo the fractional exponent, I'm going to raise both sides to the reciprocal power of 3/2. On the left-hand side, the 3/2 and the 2/3 are going to cancel, so I end up with x. And 9 to the 2/3 power on my 3/2 power on my calculator is 27. On number 26, we are using a u substitution again. I'm going to let this middle term variable equal our u. And that little block is what u is equal to. So this one I'm going to call u squared. So now I'm going to scoot this. I'm sorry about the net. That's so like in the wrong spot. I'm going to rewrite that right here. It is u squared minus 5u minus 24 equals 0. That factors very nicely because, again, it is a type 1 trinomial. After solving the variable, each factor for the u value, I'm going to get a u of 8 and a u of negative 3. But we weren't solving for u, so we come back up here and unsubstitute. Remember, that lead term never gets used again. If I unsubstitute for u, I'm going to get x minus 3 equals 8. When I move the 3 over to the other side, it becomes 11. This other u I'll replace with an x minus 3 by unsubstituting also, and we're going to end up with an x of 0. Remember, it is okay for us to get answers of 0. Now, on number 27, when you're solving an absolute value equation, you get to do it twice. So, the first time, we're going to pretend that the absolute value is not even there. For case number 2, again, pretend that the absolute value is not even there, but this time multiply the right-hand side by a negative 1. To solve for x, I'll move the 8 over to the other side. I get 7x is equal to 14. After dividing both sides by 7, you're going to end up with an x of 2. For case number 2, when I bring the 8 over to the other side, I'm going to end up with 7x is equal to negative 30. After dividing both sides by 7, we're going to end up with an x of negative 37. With absolute values, you have to do both cases in order to get full credit. Number 28 is a single radical problem. I'm going to start off by isolating him. Since he is, I'll go ahead and square both sides. On the left-hand side, the square root and the square cancel, so we get 5 minus x equals. The x plus 1 squared means an implied FOIL process, so you're going to expand it out and then do the FOIL process. We get 5 minus x equals, we'll start with the x. X times x is x squared. X times 1 is x. Then scoot over. 1 times x is x, and 1 times 1 is 1. As soon as you see the squared term, you're going to get excited, knowing that you're about to see a quadratic happening. After you move everything over and combine like terms, you're going to end up with x squared plus 3x minus 4. Luckily, this is a type 1 trinomial, so I'll factor it really quick. That is x plus 4 and x minus 1. So we're going to end up with an x of negative 4 and an x of 1 as our final answers. Our last one is a polynomial equation. On these, the very first thing you need to do is get everything over onto the same side and set equal to 0. Everything is already on the same side except the negative 54. When I bring him over, he becomes a positive 54. Now we're going to group. First two terms, second two terms together. The first two terms have an x squared in common, so we're going to factor it out. It's going to leave behind an x minus 6. Bring the negative down between the two groups. The second two terms have a 9 in common. When I factor, a negative 9 is going to be factored out of those two terms. It's also going to leave behind an x minus 6. Remember, verify by multiplying back together again if you need to. Now I'm down to two pieces. These two pieces have an x minus 6 in common. When I factor it out of the first term, it's going to leave behind an x squared. When I factor it out of the second term, it's going to leave behind a minus 9. This is also a difference of two perfect squares. We can solve it by the square root method, quadratic formula, but I'm going to factor it. This factors into x plus 3 and x minus 3. Now I can find my three answers. The first factor will give me a 6, the second factor a negative 3, and the third one a 3. You get that by setting each factor equal to 0 and solving. Good luck.